Alright, hey everybody. So what we're going to do today is talk about how to write a vector in component form. So as you can see, what I'm doing on the board is just rewriting it so that I can have it in terms of U. Not U, but the letter U. Now component form basically means you want the magnitude of the vector times its component. So the component for the x direction is going to be cosine, and the component for the y direction is going to be sine. So that's why I wrote up that formula right there. So what I'm doing now is I'm basically just plotting it like a point and creating my vector. Now the next part that I'm doing is I'm labeling each side. So the y distance is 3 and the x distance is 7. And you can pretty much get that from your vector itself. So now I'm finding the magnitude of the vector. So using the Pythagorean theorem, I'm going to do the square root of 3 squared plus 7 squared. Pull up my little calculator and I'm going to find that answer right now. So my answer came out to be 7.61. So now that I have the magnitude, the next thing that I'm actually going to need to do is figure out what angle is that vector creating with the x-axis. So I'm drawing a little theta in there on the triangle so I can figure out what angle it's forming with the x-axis. Now from class, you should know that we're going to be using SOHCAHTOA because we have a right triangle that the vector has created and we want to find out the angle. So in this case, I'm going to be using the tangent is equal to the opposite over adjacent, so 3 over 7. Now as you can see, since I moved out the way, you can see that theta is equal to the inverse tangent of 3 over 7. And always check to make sure that your calculator is in degree mode and not radians, because radians will give you an answer you do not want. Now, once I have my angle in this particular problem, I'm just going to write it down exactly as it is. In most cases, however, you're going to need to check and make sure you know which quadrant you're in and what that reference angle would create in each quadrant. And we'll do other examples at another time, probably in class where you'll learn how to know what angle it actually is from its initial value. So putting the finishing touches on this, basically I'm just writing it exactly how it says in the format. I ran out of space a little bit here on the right, but I'm pretty much just writing it exactly how it is. And a good way to check if you did the problem right is to see if what you put in for your component form can be evaluated to give you the original vector. So what I'm actually going to do is pull up the calculator and I'm going to put in 7.616 cosine 23.2 and it should give me 7. And it's kind of hard to see on the screen, but it does say 7.00. Similarly for the y, once we plug in that part of our vector, we should get something very close to 3. Once again, 3.00. So that's basically component form of a vector in a nutshell. I hope this video was helpful to you, and I'll see you soon. Bye.